Okay guys, I am going to go through the last few problems on the back of the 1.1 notes page. Some of your classes, we actually did this example, so if you need to skip ahead, go ahead and skip ahead. On this one, we were looking at the difference between solving this algebraically and graphically. No matter which way I'm doing it, the first thing I want to do is get everything on the same side. Once I have done that, I'm going to start with algebraically. It is a quadratic. I can solve it by factoring, quadratic formula, completing the square, or taking the square root. It is not set up well for taking the square root, so I'm not going to use that option. It also does not factor, so I'm not going to use that one. Most of you have said that you wanted to do quadratic formula when you saw it, so that's what I'm going to do. So I have x equals negative b plus or minus the square root, and inside my parentheses I'm going to put that b squared minus 4ac. So when you type in 4 squared minus 4 times a, so times 1 times c, which is negative 10, you can type all of that into your calculator and you just get 56. Make sure you're showing me at least enough steps so that I know what you did. But you don't have to show me every single step. Think of, I need to be able to know how you got from one step to the next, but I don't necessarily have to see every single thing that you did. Your denominator is all over 2a, so 2 times 1 is just 2. This simplifies to give me negative 4 plus or minus 2 radical 14 over 2, and then my fraction even simplifies further to give me negative 2 plus or minus radical 14. Now this is my exact answer and would be my most preferred answer. In order to compare it to what I get graphically, I do need the decimal approximations, so I'm going to go ahead and write those down as well. And I'm just typing this into my calculator. Negative 2 plus the square root of 14 is 1.742. Negative 2 minus the square root of 14 is negative 5.742. We are then going to compare this to what we get on our calculator. So on your graphing calculator, go ahead and graph that equation, the x squared plus 4x minus 10. Make sure that your stat plot's turned off if you have it on still, and just go to your standard viewing window is fine. I did that on my computer and I got this graph, and I've already done a little bit of work here. One thing that I want to remind you is that on your paper you do need to make sure you have a sketch of this graph so that I can see what it looks like, and you can mark those x-intercepts and we're going to find their coordinates. Now, because I am doing this on a screen that I'm having to capture and I don't actually have a calculator that I can do all of that with, you are doing that on your calculator. As a reminder, once you have it graphed, you're going to do second and then the trace button, which is actually calc, now that you've hit the second button, and you are trying to calculate these zeros. Now there are two, so you have to pick which one you want to start with first. I'm going to start with this one on the left. The first thing my calculator is going to ask me for is left bound, so you'll have to move the blinky cursor like over here to where it's to the left of that x-intercept. Then it's going to ask you for right bound, so you're going to want to move it like over here where it's to the right of that x-intercept. That essentially creates a boundary that you are looking between for your x-intercept. You are then going to guess when you put your cursor as close as possible to that x-intercept and then hit enter, and it will give you this coordinate, negative 5.742, comma 0, as your actual 0. Notice that it says 0 here. It does not say like 0 question mark or anything like that. You're then going to do the same thing for the x-intercept on the right. When you do that, you should get that 1.742, comma 0. You have to be able to do this on your calculator. If you cannot, and this was not helpful enough, let me know in class so that I can show you how to do it on your calculator. The next problem that we are looking at, the next thing is just a review of your terminology. So root, solution, zero, those all mean the same thing. It does not matter. You're all going to do the same thing for all of these, even x-intercept. The only difference is that an x-intercept has to be a real number. So if I was doing quadratic formula or something and I got 2i as my answer, that would count for my roots, my solutions, and my zeros, but it would not be an x-intercept because you cannot on your graph be at 2i on the x-axis. That's not a real spot. This next problem, we are looking at applying just our knowledge. So it says the engineers at an auto manufacturer pay students 8 cents per mile and $25 per day to road test their new vehicles. So I first need an equation that represents this. I'm going to use y equals just to make it as easy as possible. Since I have a flat amount every mile that it's happening every single mile, I'm getting that $0.08 or 8 cents. I'm going to make that my slope. And then I have that just every single day, beginning of the day, no matter what, I get that $25. So this is an equation to find out how much they're going to get per mile, or overall for the number of miles driven in one day. On A, ask how much did the auto manufacturer pay Sally to drive 440 miles in one day? So you should be doing y equals 0.08x times 440 plus 25. That can go in your calculator. When you do that, you should get $60.20. For the part B, I'm telling you that John earned $93 one day. I want to know how far he drove. So that's 93 equals 0.08x plus 25. And then you are solving that for x. As a check, when you do that, you should have gotten that he drove 850 miles. The next two problems, we are actually going to look at just some issues with using our graphing calculator. So on this one, it says look at the graph of y equals 3 minus, then you have that fraction of 1 over the square root of x squared minus 1 in the z decimal window on a graphing calculator. So graph it and then hit zoom, and you should see z decimal is an option. I have included that graph here so you can see what it looks like. According to this graph, I'd say no, there's not any x-intercepts. However, you cannot always rely on your graphing calculator to show you exactly everything you need. That's why we have the algebra tools as well. So I look at this graph, it looks a little bit weird to me. That's what triggers me to actually check to see if it's accurate. So I'm going to solve this algebraically as well. So I'm going to set it equal to 0 so that I can algebraically find these zeros. When I am solving this, I would probably add that fraction over to the left side. So I have 1 over the square root of x squared plus, minus 1 equals 3. This is just like a normal equation that you're solving. I'm trying to get the x by itself. I first need to get it out of that denominator, so I'm going to multiply it over. So I have 1 equals 3 times the square root of x squared minus 1. I would really like to get rid of this square root. I cannot do that until I get to where that's the only thing on that side. So I'm going to divide my 3 over. And now that the only thing on the right side is that radical, I can square both sides. So I am squaring both sides. When I do that, 1/3 squared is 1/9. And on this side, I just have x squared minus 1. I'm going to add my 1 over, which, because I don't want to have to deal with a mixed number, that will give me that improper fraction of 10/9 equals x squared. When I do the square root of that, I get x equals plus or minus, because I do have a positive and negative, square root of 10/9. I can go ahead and simplify that and say plus or minus the square root of 10 over 3, or approximately plus or minus 1.054. I show you this to remind you that your calculator is a tool. It is not perfect. So it looks like there's not any x-intercepts, but there totally are. Again, it's because it looks weird that I'm like, this seems odd, let me check it. So I'm going to check it algebraically. I have one more I want to look at with you. So if you were to graph, and I would recommend doing this in a minute, this cubic on your calculator in that standard viewing window, so -10 to 10 for both the x and y, you get that picture on the left, which is kind of hard to tell what the heck is happening. So sometimes my calculator, it graphs everything exactly what it's supposed to, but it doesn't truly show me what's going on. So I need to change my window or maybe zoom some, and a lot of the times it is messing with your zoom, zooming in, zooming out, to try to get an idea of what you need that window to be so that you can start problem solving. I will say, since I have this plus 229.5, that would be my y-intercept. I might try by changing my window so that I can see a lot of that y-axis and see those values. Now I do see that I can see all the x-intercepts, because with a cubic I would never have more than 3. I have 1 right here where I can see it crossing the x-axis, and right here I actually have 2. It's called a double root. I know there's 2 because it hit my graph and bounced back off. It did not go straight through it. So I have all 3 of my x-intercepts, so I'm not concerned with changing my x-axis, but I did change my y window to go from -500 to 500, and now I really do get a better picture of what's happening with my graph. So again, your calculator is a very, very useful tool. It is not the end-all be-all. You have to learn how to work with it.